First thing we're going to talk about to review for our test on Thursday are the section over points, lines, and planes. So we went over a few different vocabulary words, and I just want to do a few illustrations for you just as a reminder of the different vocabulary words that we did cover when we went over points, lines, and planes. The first was talking about collinear versus non-collinear. So remember that these words are telling me whether or not points can create a line. In order for something to be collinear, okay, I need to have two or more points. Any 2 points can create a line. Okay, it doesn't matter where the points are located in space, I can connect them and create a line. For points to be non-collinear, I need to have 3 or more points. So non-collinear means that I have 3 or more points that are not on the same line. Okay, so to illustrate that, I'd have 2 points or more that are on a line. That's my collinear. For my non-collinear, I would have 3 or more points not on the same line. So you can be asked a question dealing with collinear or non-collinear just on a straight line, or your collinear and non-collinear could be on a 3-dimensional figure like a rectangular prism or a triangular prism, which we'll look at in a second. We talked about segments and rays and lines. Now one thing I want you to remember, if I have a ray, okay, and a lot of people on the quiz didn't do this correctly, okay, if I have a ray, if I draw a line and I want to name a ray that is on this line, say this is A, B, and C. Okay, a ray has a starting point and an ending point. But this isn't naming a ray. I just have written down the letters B and A. That doesn't count. Okay, I need to draw the ray above it pointing to the right to show that it is a ray. If you just put BA without the actual ray above it, okay, I'm not going to give you credit for it. I'm going to count points off. I'm understanding that you're talking about from B to A, but I don't know whether that's the segment BA or the ray BA, so you need to be specific about that. Okay? And that also holds true with segments. If I have a line, let's say I have the same exact line, I have A, B, and C. Okay? I can't just write down segment AB. Okay? That doesn't tell me enough. Okay? This isn't telling me enough. It needs to be AB with the line segment above it. Because again, I could be talking about ray AB. Alright, so in rays, segments, and lines, I really want you to focus on making sure that you're labeling everything. So on your paper right now, write down, make sure you label rays, lines, and segments. We talked some about opposite rays too. So let's say we have a line. It's drawn. Say we have 4 points, M, N, O, and P, and we want to name a pair of opposite rays. So understand the vocabulary there. One pair means one set. So if I ask you for 2 pairs, I want 2 different sets of opposite rays. So remember that rays, opposite rays, start with the same endpoint. So let's say I want a ray opposite of NM. Well, opposite of NM, N is my starting point going towards M. Going the opposite direction would be N to O or N to P. Either one of those is acceptable. Okay, so that would be one pair of opposite rays. Right? If we started with O, O to P, I start at O, go through P and continue on. That means my opposite ray also starts at O, but goes in the other direction. So either ON or OM. Either one of those would be correct answer. Again, I'm labeling my rays above that. Alright, let's get into 3-dimensional figures. Okay, so on here, I'm going to draw a triangular prism. Okay, so I'm going to draw my triangle. My line's coming off of my triangle. and then my dashed lines that are not seen. I'm going to go ahead and label each point or vertex of my triangular prism here with a letter. Now let's talk about the different pieces of this triangular prism. First of all, I have a certain number of faces. I have my 2 triangles and my 3 rectangles. That means I have 5 total planes. If I wanted to name a plane, okay, on my figure, I need to name 3 of the letters that are a part of the shape. Okay, for example, obviously this front triangle, okay, is plane ABC. Okay, so plane ABC is that front triangle. Now, if I wanted to name a plane for one of the rectangles, one of those faces, okay, I would say, let's say I wanted to name this rectangular face here. That means I need 3 of these 4 letters as part of my plane name. So let's say I pick B, C, and M. So plane BCM represents that whole entire rectangle, and that would be my plane. So when you name planes, make sure you're naming them with 3 letters. Planes need to be named with 3 letters. Okay? Also, we talked about parallel lines within these prisms. BN and CM are part of the same parallel line. Okay, are parallel lines that are part of the same shape. BC and NM are parallel lines. But then we brought up that word skew. Skew lines meaning 2 lines that are not parallel, but they will never intersect. For example here, let's look at this line CM and this line ON. If these lines continued on forever and ever in space, they would never intersect with one another. They are not parallel. BN and CM are not skew lines, they're parallel lines. Okay, so if I was to name a set of skew lines, I'd say segment CM and segment ON. Okay, those would be known as my skew lines there. Okay? So make sure that on your test you understand on the triangular prism that the skew lines are not parallel, because that was a mistake that was made by some people on the quiz. If I ask for parallel planes, okay, parallel planes are just like parallel lines. They're going to be parallel to one another. Now the only ones on this triangular prism are the 2 triangles that are parallel. Remember, just like parallel lines, parallel planes will never intersect if they continued on in space. So these triangles here would never intersect. These rectangles are intersecting at every one of those edges. All right, so make sure you remember that in terms of parallel planes. Okay, for on level, you're going to be tested over midpoint and distance. If you're in pre-AP and watching this, you're not going to be tested over it because you're doing it on your global vacation project, so you can fast forward through the video. Okay, but for on level, remember from midpoint and distance, we're taking 2 coordinates and finding their middle point and then the distance between the 2. Okay, so if I have a coordinate, let's say I have a coordinate at 5, -3, and another coordinate at -2, positive, we'll say positive 5. Okay? 5, -3, and -2, positive 5. In order to find the midpoint, I'm going to go through 4 steps. Step 1 is to add my x values together. 5 plus -2. Step 2 is to take that answer and divide it by 2. 3 divided by 2 is 1.5. So 1.5 is going to be the x value of your midpoint. Step 3 is to do the same process but with your y values. -3 plus 5. The next step, take that answer and divide it by 2. That becomes the y value of your midpoint. So you would have 1.5, 1. If you want to find the distance, again this was the midpoint, if you want to find the distance between those 2 points, you're going to go through another process. Step 1 is to figure out what the distance is between 5 and -2 on a number line. That's your change in your x value. Between 5 and -2, I have 7 units. That's going to go in for my A in my Pythagorean theorem. Between -3 and 5, I have 8 units. So that's going to go in my b for my Pythagorean theorem. And now I have 7 squared plus 8 squared equals c squared. And I'd go through and solve by squaring those numbers, adding those numbers, and then taking the square root of 113. Okay? So that's how you would use the distance formula. Alright? Another part of midpoint that we talked about was, what if I have an end point given? Like, let's say I have an end point at 5, negative 2. And my midpoint is at 10, 7. How can I figure out what my other endpoint is supposed to be? So when we talked about this, we went through an algebraic process, but the shortcut here is to say, okay, I know that I have 5 units, or I have to add 5 units to 5 in order to get 10. So I'm going to do that same exact process from my midpoint in order to get my new endpoint. So 10 plus 5 is 15. And then I look here with my y values. In order to get from negative 2 to 7, I have to add 9 units. So I'm going to do the same thing to this 7 in order to get my new y value for my endpoint, which would be 16. So if I am given an endpoint and a midpoint, I figure out what operation was done to get from my x1 to x2 or y1 to y2, okay, and go from there. All right. So that's how I would go about that process. Okay, the last couple things that we've talked about are the different types of angles. So you have complementary and supplementary, and the main things to remember are those definitions. Remember that complementary angles add up to 90. That supplementary angles add up to 180 degrees. Know what a straight angle is, an obtuse and an acute. You're going to have to illustrate those. Pre-AP and on-level is going to have to illustrate the whole process of what type of angles they are, complementary, supplementary, and have to create those problems. Pre-AP, we went through a section on measuring segments. Look through your notes on measuring segments. Okay, make sure that you're able to see a coordinate on a number line and find the distance between the two. Okay, that is all for this review session. If you have any other questions, remember to ask me in class on Wednesday, since this is going to be placed on the internet on Tuesday night.